6.3. We're going to be doing the accumulation function again. FTC. Accumulation function is the FTC. Okay, recall FTC. 2 parts. First part. If g of x is equal to the integral from a to x of f of t dt, then g prime of x is equal to f of x. Okay, we already know this, so just review. If g is the integral of f of t from a to x, meaning g is a function of the area underneath f, then when you take the derivative of g, it is just f of x. Okay, that's the first part. Second part, integral from a to b of f of x dx is equal to big F of b minus big F of a, where f is any antiderivative of f, that is f prime is equal to, big F prime is equal to f. You really don't need to copy this down because this is just the same as FTC that we've been doing for like the whole last chapter, and you probably wrote this down at least 2 times. But these are the 2 big points of FTC, and we are going to just kind of use them again. Okay, suppose that f is the function whose graph consists of straight line segments and 2 quarter circles as shown below, defined as g of x is equal to integral from 0 to x of f of t dt, and this function here is f. Figure out what each one of these are. That should be pretty easy. Okay, I'm gonna leave this up here. G of 0, G of 1, G of 2, G of 4, and G of 6. Okay, go ahead and figure out what those things are. Remember that G of x is equal to integral from 0 to x f of t dt. All right, let's see. Okay, let's start with Kevin. What is g of 0? 0. Okay, g of 0 is 0. Wendell, what is g of 1? 1. Jessica, g of 2? Joyce, g of 4? You didn't do that one, Chris? No. Yvonne? 3 plus pi. How would g of 6? You didn't get that one, Jonathan?
G of 6, just 3.
Yes. Okay, so you want to find the area underneath the curve. Okay, so everyone's good up to 2. Okay, g of 4 is this area, right? So it's everything up to 2, which we already know is 3, plus the quarter circle. The quarter circle has a radius of 2, so the whole circle is pi r squared, so pi r squared, but it's a quarter, so divide by 4, and that is pi. So it's 3 plus pi. Okay, and then this part is pretty easy. You can see that it's exactly the same quarter circle, but in a negative area, so you're going to subtract it out, so it's going to be just back to 3. All right, next. All right, let f be a function defined on the closed interval -4 to 4. Initial condition is f of 0 is equal to -3. The graph of f prime is shown below. Okay, I don't know if you guys want to just kind of copy down the shape because I'm going to go through the problem, so it's easier if you have the shape on your paper. All right, let's go through the first question, or I think you should be able to answer the first question. On what interval, if any, is f decreasing? Justify your answer. Please justify your answer in terms of f or f prime, because that's what's given. Okay, so go ahead and do that one. Where is f decreasing? Okay, maybe this would be a nice tip. Whenever they say f is decreasing, you should immediately write f prime is less than 0. That way you know what you're looking at. F is decreasing, just, okay, I am looking for the derivative less than 0. All right, Chen, do you have an answer? Where is it decreasing?
From 2 to 4.
Yeah, from 2 to 4. And the reason?
Those is over the x.
Yeah. Okay, so you want to just be specific and say f prime of x is less than 0. Okay, so some of you, when I check your Muddy special, you would say because it is or because the function. You have to be specific which function, because they're going to pick at you and say, like, you're not specific enough. What function are you talking about? F prime, or, what else are you talking about? So make sure you justify that way. Find the x-coordinate of each point of inflection on the graph of f in the open interval -4 to 4. Justify your answer. Okay, point of inflection. This is a little tricky because people always give me the wrong thing. What does point of inflection mean? First, you had to check what?
Change in sign.
Of what? Huh? Yes. Okay, so yes, Kai is right. Change of sign in f prime, or f double prime has to be 0 or undefined. Okay, those are where the points are, and then like Kai said, it's where the sign changes for f. No, not f prime. F double prime. Okay, so this is another thing that people will say incorrectly. So they know what they're doing, but then when they justify it, they write it wrong. So how do you know something is a point of inflection? F double prime changes signs. Or f prime changes from increasing to decreasing. A lot of people will say something like this. F prime changes signs. No, it doesn't change signs. F prime changing signs is this changing signs. This changing signs means that you have a critical point, not an inflection point. Does that make sense? If you're going to talk about f prime, you're going to talk about increasing, decreasing, meaning the direction change, not the sign change. When you say sign change, you meant from positive to negative. Okay, so they're also going to pick on that. Okay, all right, too much information. Okay, go ahead and figure out where the point of inflection is. Okay, Sarah, where is or where are the point of inflection? -2 and 0. And why? Yes, but you're not talking about which function is increasing or decreasing. You're just saying it's double prime is not increasing, decreasing. Okay, this is f prime, right? So you're saying from -2 and 0 are point of inflection, which is true. But when you're saying increasing, decreasing, you're talking about direction. So f prime is changing direction. F double prime has sign change. Okay, so this is f prime, right? F prime is this graph here. F double prime, this is negative, so it's going to be like this, and then this, I'm doing this wrong. Okay, this, and then something here. Something like that. So this is f double prime. So basically what happens is f double prime has a sign change, right? It changes from negative to positive and then positive to negative. F prime has a direction change. Are you guys with me? Okay, please be specific. People always make mistake on this part. All right, so that is the point of inflection. It is not enough that you said it is a point of inflection because f double prime is 0 or undefined. That is not the definition of point of inflection. It has to have a concavity change, or f prime has to have a direction change, or f double prime has to have a sign change. Okay, point of inflection is not exactly the same as critical point. Critical point, as long as it's 0 or undefined, it is a critical point. Point of inflection has to have a direction or sign change or whatever you're talking about, the concavity. Okay. Next, find an equation for the tangent line tangent to the graph at the point 0, -3. All right, go back to last semester. Tangent line. You need two things for tangent line: slope and point. All right, we need two things for a tangent line: f of 0 and f prime of 0, right? F of 0, they told us, is -3. F prime of 0, look at the graph, right? The graph is the slope graph, so that's 2. So then y minus -3 is equal to 2 times x minus 0, so that's it. Next, find f of -4 and f of 3. F of -4, when they give you a actual number at 0, so then you can do something like this. Integral of 0 to -4 of f of x, f prime of x, sorry, is going to equal f of -4 minus f of 0. Right? That's FTC number 2. Now you have to figure out what to do with all these limits and actually fill in all the numbers. Okay, so to do this question, first of all, when you see this, you're like, how do I even do this? You got to remember FTC number 2, which says this thing applies. If you don't, it may take you a while to figure out the answer. Okay, so first, you can see that this integral is in the wrong position, so we gotta swap it. Then you look at from -4 to 0, and you look at that shape, and you ask yourself, what is the area underneath the curve? That is going to be -8 minus 2 pi. Okay, and then f of -4 is what we want, so we don't know what that number is. F of 0 is -3, so that's +3. So that is -8 plus 2 pi equals f of -4 plus 3, so that is -11 plus 2 pi, which is f of -4. All right. Let's have you guys try f of 3 if you didn't do that yet. F of 3. Okay, so the integral from 0 to 3 of f prime of t dt is equal to f of 3 minus f of 0. Okay, from 0 to 3, let's see, from 0 to 3 it is 1.5. Okay, 1.5 is equal to f of 3 minus minus 3. So then subtract 3, that's negative 1.5. Okay, let's try another one. Oh, this one is kind of fun. That being said, it's kind of crazy.
Are we allowed to use calculators?
No, there's nothing to use a calculator on. It's another graph.